Okay, hello everyone. My voice is audible to all of you. Josefa, Maziha, Noma, Uneep, my voice is audible. Sorry, Noma, I can't hear you. Uh, Please reply me on the chat box if anyone have an issue with your mic. Okay, Noma, good. Josefa, Maziha, and Uneep, my voice is audible. Okay, Josefa, good. Uneep, my voice is audible. Okay, very good. Okay, so I hope everyone has revised the previous topic. Okay, please remember relation and function is a tough chapter. That's why we will try to complete most of the questions in the class only. Okay, I will not give you much homework in this chapter. But in differentiation, there are certain topics which are quite simple. So in differentiation, you need to solve many questions in the homework. Okay. Okay, so a quick viva for 2 minutes. So Uneep, first question is for you. What is a symmetric relation? Uneep, what is a symmetric relation?
Sir, if in a relation A comma B belongs to R and B comma A belongs to R.
Very good. Then Josefa, what is a reflexive relation? Josefa, what is a reflexive relation? Josefa, please reply me on the chat box if you have some mic issue. Yes, Josefa, what is a reflexive relation? I can hear the background noise, Josefa, but not your voice right now. Yes, Josefa.
Yes, sir.
Yes. What's a reflexive relation?
Uh, I am not sure, sir.
You don't remember? But Josefa, I already told you to revise all the topics of this chapter before the class. Okay, there's a tough chapter. So please revise all the topics. Okay, Noma, what is a reflexive relation? Noma, what is a reflexive relation? Noma, your voice. Okay. Yes, Noma, your voice is not audible. What is a reflexive relation? Yes, very good. Now next question is for Mazia. Mazia, what is a transitive relation? Mazia, your voice is not audible.
Hello.
Yes, yes, Mazia. Now it is audible. What is the transitive relation?
If um,
If AB belongs to R and BC belongs to R,
if
then
AB belongs to BC, then
yes,
BC is belongs to R.
then AC should also belongs to R. Hmm? Am I correct, Noma? Okay, then Josefa, the last question is for you. What is the equivalence relation?
If it's reflexive, symmetric, and uh,
Yes, if a relation is reflexive, transitive, and symmetric, then we
yes,
will call
transitive.
it a equivalence relation. Very good. Okay, so we will try some questions on the basis of these topics. And I hope everyone has completed the homework of determinants. Okay, so I have not checked it yet. I will check it tomorrow. So if anyone is left, then please submit the homework till tomorrow. Okay. Okay, so this topic we have already completed, equivalence relation. Now we will try this question. Check the following relation Rn is for reflexivity, symmetry, and transitivity. Okay, so this is the first relation. We need to check that this relation is reflexive or not, this relation is symmetric or not, and this is transitive or not. Okay, so let me solve this question. So first part. First part is this means relation A is related to B, and what is the relation? B is divisible by A, and what is A and B? AB belongs to natural number. Okay, so for the first part, in part A, we will check for the first point, reflexivity. Okay, we will check for this. So first of all, we will write like this: for all A belongs to natural number. Okay, A is divisible. A is divisible by A. This implies A is related to A. Okay, hence A is related to A for all A belongs to a natural number. So R is a reflexive relation. So R is a reflexive relation on N. Okay. So first thing is, what is this relation? Divisible by. So we know this point that every number, every natural number is divisible by itself. If we will take example 2, then 2 is divisible by 2. If you will take a 3, 3 is divisible by 3, 4. So that means every number is divisible by itself. Okay. So that means this should be a reflexive relation. Okay, but how can we prove this? We will assume, okay, that let A belongs to natural number. A is divisible by A. This implies A is related to A. That's why this is a reflexive relation. Okay, so Josefa, Mazia, Noma, Unip, this is clear, the first one. Joseph, okay, Mazia, I got your message. Josefa, Noma, and Unip, this clear? Okay, good. Then Noma and Unip, first one is clear. Okay, Noma, I will. Munib, this is clear?
Yes.
Okay, very good. So Noma, first of all, please check the question. The question is B is divisible by A. Okay. So what is a reflexive relation? We will say a relation is reflexive if every element is related to itself. Okay, that means all, and what is the set? Set here is natural number. So that means inside this natural number, all the elements should relate it to itself. Now, what is the relation? Relation is B should be divisible by A. Okay, so that means every number for reflexivity, that means every number should be divisible by itself. If we will check this, 2 will be divisible by 2, 3 will be divisible by 3, similarly 4 will be divisible by 4. Now, so we will write in this way. The issue you will face is how to represent your answer. Okay, in relation and function, the main issue you will face is how to represent your answer. That's why we will try to solve most of the question in class only. Okay, so the first is for reflexivity, we are saying that for all A belongs to natural number, we have assumed an element A which belongs to natural number. Now we know that if we have a number A, that number will be divisible by the same number A. Okay, so we are writing here A is divisible by A. This implies A is related to A. Okay, and the same thing we have repeated here. So that means A is related to A for all A belongs to a natural number. That's why R is reflexive relation or N. Okay, this is a way of representing your answer. Noma, now is it clear? Okay, very good. So always remember one point. If you have to prove any question that this is true, okay, which we have done in this case, then you need to represent like this. But if in a question you need to prove that it is false, then you can give just a simple example. You can give just an example which is false. Then on the basis of that example, you can say the complete equation is false. But the same case will not be taken for the condition of truth. Okay. So for the symmetry, if it is not symmetrical, if the relation is not symmetry, then please give me an example for which this relation is not symmetrical. Okay. So please try the second part. Please try this. Let me know. I will give you 2 minutes for this question. And if anyone have a doubt, then please let me know. Then I will solve it. Okay. So Noma has given the answer 1, 2 and 2, 1. Very good. This is correct. Okay. So next is symmetrical. Okay. Now, if you need to prove that it is false, then please just give a simple example. Now, for example, let the answer which Noma has shared is this: let 1, 2 belongs to relation R. So this is true. 1, 2 belongs to R. Okay. And before that, we will write 2 is divisible by 1. 2 is divisible by 1. Okay. This implies 1, 2 belongs to R. Okay. And we will write over here that what is 1, 2? 1, 2 are the natural number. Okay. 2 is divisible by 1. So that's why 1, 2 is belongs to R. But 1 is not divisible by 1 is not divisible by 2. 1 is not divisible by 2. Hence 1, 2, sorry. Hence 2, 1 does not belongs to R. Okay, 1, 2 belongs to R, but 2, 1 does not belongs to R. So R is not on natural number n. Okay, so I hope this is clear to everyone. Sorry, Noma, next. Noma, you're saying what about 2, 2? Okay, so Noma, what I was telling, if you have some conditions, okay, and that condition is true for 99 cases. Okay, if you have a condition and that is true for 99 cases, but there is one case for which that condition is not true, then ultimately we will say that the condition is false. Okay, so if we will take almost 1,000 example for which this condition is true, and we have a one case for which this is false, then ultimately we will say that this is not symmetric. Okay. So it's not symmetric on. Okay. Okay. So Josefa, Maziha, Noma, Unip. This part is clear. The second part. Okay, Maziha. Unip, Josefa. Okay, Noma, good. Unip and Josefa, this is clear. Yes, Unib, this is a very good question. So Unib is saying that is it necessary to write 2 is divisible by 1 as 1 comma 2? Okay, yes, it is. Please check here, Unib. It is written here as A or B if B is divisible by A. Okay, so what they have done, the second element they have taken in the beginning. So they are saying that B is divisible by A. Check this condition. Okay. So that's why we are saying if we have written this one is not divisible by 2. So we have written over here 2 comma 1 does not pass to R. This clear, Manip?
Yes, sir.
Okay. So I hope this is clear. Please note down this one and let me know so that we can start the third part. Okay. Please message me once it is done so that we can start the next part, third one. This is done. Josefa, Mazia, Noma, and Anip. Shall we start next? Okay, Noma. Everyone, this is done. Shall we start next? Maziha, Unib, Huzefa, this is done.
Yes.
Okay. Okay, Maziha. Huzefa, shall we start next? Huzefa, this done. Huzefa, please reply on the chat box. Shall we start next? This done. Okay, great. Okay, so R is not symmetric. Now the third part is transitive. So anyone can tell me this is transitive or not. I will solve this, but first of all, please tell me this condition. B is divisible by A, it is transitive or not? No answer. Let me check here. We will assume three elements. Let A, B, C belongs to natural number. Okay. So such that A comma B belongs to N. Sorry. It will be transitive. Okay, only very good. Such that so it is, if it is transitive, then we can't give any example. We need to prove it. Okay. Such that AB belongs to R. We have taken three elements. Okay. And BC belongs to R. Okay, we assume that such that AB belongs to R and BC belongs to R. So that means B is divisible by A. B is divisible by A and C is divisible by B. And C is divisible by B. Okay, B is divisible by A and C is divisible by B. So that means, so this implies, okay, please check here. If B is divisible by A, for example, if we are taking 4 is divisible by 2. And if you will say we have a 12 is divisible by 4. So ultimately 12 will be divisible by 2. Okay, so B is divisible by A, C is divisible by B, then this implies C is divisible by A. Okay, so A comma C belongs to R. Okay, now we will write here A comma B belongs to R and B comma C belongs to R. So this implies A comma C also belongs to R. Hence it is transitive. Hence it is transitive. Okay. So in the beginning of the question, you need to check it is transitive, reflexive, or symmetric or not. If it is false, then please give a simple example. If that is true, then proof like this. Okay. So please let me know if anyone have a doubt in this. Otherwise, please note down this and then we will start the next question. Okay, Noma, C part is not clear. Noma, please check here. Suppose Noma, we have 3. Okay, now we are saying 9 is divisible by 3. Okay, and we are saying 27 is divisible by 9. Then can we say that 27 is divisible by 3 also? Noma, this is correct. Okay, so what does this mean? This means 3 comma 9 belongs to R. Okay, so this means 9 is divisible by 3. This means what? 9 comma 27 belongs to R. What does mean by this? This means 3 comma 27 belongs to R. Okay, now check this. 3 comma 9 belongs to R, 9 comma 27 belongs to R, and 3 comma 27 belongs to R. These two are common. Okay, so that's why we will say that this is transitive. This clear? But how is it true for all natural numbers? So I've just given an example so that you can understand. This is a formula which will be valid for all the numbers. Okay, you will not find any of the number which do not satisfy this. Please check here. The 3 is smaller than 9 and 3 is dividing this 9. Okay, so that means in 9, if you will do the factors of 9, then you will get a 3 into 3. Now, if 9 is dividing this 27, then you will, and if you will find the factor of 27, then one of the number will be 9. Okay. Inside this 9, you have 3 as a factor. Inside this 27, you have a 9. And 9 already have 3 as a factor. So that's why this 3 will divide this number also. So the same logic will be valid for all natural numbers. Okay. Okay, good. So everyone, please let me know if this is done so that we can start the next question. Josefa, Mazia, Noma, Unip, this is done. Shall we start next? Okay, Josefa, good. Mazia, Noma and Unip. Okay, Noma. Okay, Unip. Mazia, this is done. Okay, good. Noma, please let me know once it is done. Okay, Noma, very good. Now, please start this question part second. Okay. L1 this is a relation, S is a relation. Okay. Normally, we are using R in place of relation. In this question, they have given S as a relation. Now, what is the relation? L1 is perpendicular to L2, where what is L1 and L2? L1 and L2 are straight lines in a plane. So for this second one, first of all, we will discuss about the reflexivity. Okay. So anyone can tell me that this is reflexive or not. Anyone can tell me that this is reflexive or not. Josefa, Mazia, Noma, Uni. Okay, Noma, this is reflexive. Okay. Josefa, Uni, and Mazia, this is reflexive or not? Yes or no? Okay. Josefa, Mazia, Uni. Yes or no? Reflexive or not? So you have just two options. Okay, Josefa. Mazia and Uni, it is reflexive or not? Mazia and Unib, this is reflexive or not? Okay. Mazia, yes or no? Okay. So you are saying this is reflexive. Okay, Noma. Okay, Noma. So now you are saying this is not reflexive. Okay. Now we will check what is the condition of perpendicular. Suppose we have this line L1. This is perpendicular to second line L2. This is L2. Okay. And the angle between these two lines should be 90 degree. So they have given this condition that two lines should be perpendicular. Now suppose if we have this line, we have this line, okay, L1, and the same line will lie on this one. Now the angle between L1 and L2 will be what? That is 0 degree. Okay, this is not 90 degree. So a line can not be perpendicular to itself. So we will write the statement, a line cannot be perpendicular to itself. Hence relation S is not reflexive. Okay, so a line cannot be perpendicular to itself, hence relation S is not reflexive. Okay, this is clear to everyone. Uneep, Huzefa, Maziha, Noma, this is clear? Okay, Noma. Maziha, Huzefa, Uneep. Okay, Uneep. Maziha and Huzefa, this clear? Okay, good. Okay, so please note down this reflexive part and tell me the second one. Okay, symmetric. Please tell me the second part. This relation S is symmetric or not? Okay, Noma, your answer is correct. Huzefa, Maziha, Uneep. Okay, Uneep, good. This is correct. Huzefa and Maziha. Okay, Huzefa, good. Maziha. Maziha, this is true or false? This relation is symmetric or not? Yes, good. So if we have the relation that L1 is perpendicular to L2, this is L1, this is L2, and these two are perpendicular. Okay, then L2 is also perpendicular to L1. So that means this is symmetric. So we will write like this: L1 is related to L2. This L1 is perpendicular to L2. Is perpendicular to L2. Okay. L2 is also perpendicular to L1. Okay. Or we can write like this by using the symbol which are given in the question. L1 is perpendicular to L2. Okay. This implies L2 is also perpendicular to L1. Hence, L2 uh, L2 is related with L1. Okay, hence it is symmetric. Hence it is symmetric. Okay, in the question they have given us L1 is perpendicular to L2. This is the relation L1 is perpendicular to L2. Now we have proved that L2 is also perpendicular to L1. Hence L2 is related with L1. Hence it is symmetric. Okay, this is clear. Huzefa, Mazia, Noma, and Uneep. This is clear. Okay, okay, good. Please note down this, confirm me, then we will start the third part. Everyone, please confirm me on the chat box if this is done. Then we will start the third part, the transitive. Okay, Numa, good. Huzefa, Mazia, Unip.
Yes, sir.
Okay, okay. Then please check for transitive, okay? Okay, so for transitive, I got the reply from Noma. Very good, Noma. This is correct. Huzefa, Mazia, and Unip, just tell me this is transitive or not. Okay, and Noma, your example is correct. Very good, Unip. This is correct. Huzefa and Mazia, this done. Huzefa and Mazia, this is transitive or not? Yes or no? Just tell me yes or no. Okay, Mazia. Unip, oh sorry, Huzefa. Huzefa, this is transitive or not? Huzefa, this is transitive or not? Okay. Sorry, Josefa, I missed your answer. Very good, Josefa. This is correct. Mazia, please check here. Suppose we have a line L1. Okay. L1, this is perpendicular to L2. We have a line L1 which is perpendicular to L2. Now we have a third line which is L3, which is perpendicular to L2. Okay, we have a third line which is perpendicular to L2. Now check the relation between this line and this line, L1 and L3. Okay, check the relation between this L1 and L3. These two lines are not perpendicular. So this will not be transitive. Okay, so we will check this. Let L1, okay, so in this case, we need one more line. So what we will do, first of all, we will let L be the set, let L be the set of, okay, let L be the set of all straight line in a plane. Okay, let L be the set of all straight line in a plane. Let L1, L2, L3 belongs to L. So we have assumed this L be the set of all straight lines in a plane, and these lines L1, L2, L3, this belongs to set L. Okay, because we need a one more line L3, that's why we have taken this set L. Such that L1 is perpendicular to L2. Okay, which will give us L1 is related with L2, and L2 is perpendicular to L3. This means L2 is related with L3. So L1 is perpendicular to L2, L2 is perpendicular to L3, and now in this figure we have already checked that L1 is not perpendicular to L3, but we will write here, but sorry. So we will write here L1 is, but L1 is not perpendicular, but L1 is not perpendicular to L3. Hence L1 is not related with L3, not related. Okay. Hence it is not so it is not transitive. So it is not transitive. Okay, this clear? Josefa, Mazia, Noma, Anuni. Josefa, Mazia, Noma, Anuni. Okay, Noma. Good. Mazia, Unib, and Josefa. Okay, so I hope this is clear to everyone. So please note down this. Sorry, I'm again showing you that answer. So please note down that, confirm me. Okay. So then we will start the next question. Okay. Okay, so everyone, this is done. Shall we start next? Okay, so I hope everyone has completed this. So shall I rub it and then we will start next one. Okay, so if anyone have a doubt in the last one and the last question, then please let me know. Otherwise, please start this. Okay, so you need to show that this is reflexive, symmetric, but not transitive. So start with the first one. We will check the question. Question is, you have a relation R1 on the set R. Okay, you have a R1 is the relation, set is R, and this is the condition AB belongs to R1. This is the condition 1 plus AB is greater than 0 for all AB belongs to R. Okay, you need to show that R1 is reflexive and symmetric but not transitive. Okay, so start with the first one. First of all, show that this is reflexive. Okay, I will give you 2 minutes for this and let me know if anyone have a doubt in this one. This is a very, very simple question. Okay, so shall we start? First of all, please tell me, anyone have completed this? Josefa, Mazia, Noma, and Uni? This done? Noma,
Yes,
Josefa.
sir.
Okay, so Uni, can you tell me how can we solve this?
Sir, AB would be greater than -1.
Okay, okay. Then,
Sir, first we would write the given and all, AB belongs to R and all these things. And
mhm.
then since multi would be
uh,
equal to B and B.
then multiplication A into A will be greater than -1.
Yes, sir.
Okay, okay, very, very good. All of you, please check here for reflexive. What we will do, we will assume let for reflexive, what we need, we have this relation AB belongs to R1. Okay, this is the relation. Now, for reflexive, what we need to prove? Only A comma A. Okay, A comma A, B comma B, anything. So first of all, we will assume let A belongs to, we will assume this A from the set. So Mazia, what is the set given in this question? Okay, Noma, very good, Noma. Mazia, what is the set given in this question? Let A belongs to what? Mazia, Mazia, what is the set given in this question? Mazia, please reply me on the chat box. Unmute yourself. Josefa, what is the set given in this question? Josefa, the question is clear to you? Are very, very good. Maziha, this question is clear to you? Okay. So for reflexive, first of all, we need to assume let A belongs to R. Okay, A belongs to R. Now, 1 plus A into A. Okay, so this will be, please check here. This is 1, this is plus. Now, what are the possibilities you have if A belongs to any real number? Then A can be negative or positive. If A is negative, then negative into negative will become positive. If it is positive, then it remain positive. So in either of the case, 1 plus A into A will be greater than 0. Okay. So 1 plus A square will be greater than 0. So this means, so this implies A comma A belongs to R1. Hence R1 is reflexive. Hence R1 is reflexive on R. Okay, this is clear. Josefa, Noma, Unib, and Mazia, this is clear?
Yes.
Okay, good. Mazia, Unib, Mazia, this is clear. Josefa, this is clear. Okay, now we will start next one, part B. Next is symmetric. Okay, this chapter is very difficult. So if anyone have a doubt, then please let me know. Okay. Now for symmetric, anyone can tell me this is symmetric or not? Unib, Noma, just tell me this is symmetric. Okay, this is symmetric, already given in the question. Okay. Now the same thing, let AB belongs to R and A comma B belongs to R1. Okay, this implies 1 plus AB is greater than 0. If 1 plus AB is greater than 0, then 1 plus BA should also be greater than 0. We have just interchanged these two positions. If this complete statement 1 plus B is greater than 0, then this implies B comma A should also belongs to R. Okay, so A comma B belongs to R, R1. This implies B comma A belongs to R1. Hence R1 is symmetric. Hence R1 is symmetric on. Hence R1 is symmetric on R. Okay. Okay. So Unip, Noma, this is clear. Second part. Okay, Noma, good. Unip. Okay, Unip. No, Mazia and Josefa. This part is clear. Part B. Okay, Josefa, very good. Mazia, you have not replied yet. Part B is clear, Mazia? Okay. So everyone please note down this, confirm me, then we will check for transitive. Okay. Now in the question, they're saying that it is not transitive. So just give me a simple example. Okay, for which this is not valid. So for not transitive, for not, we will just give a simple example. We will not prove like this. Okay. So everyone please try to find an example. Zephyr, this is done. Shall we start next? Transitive. Okay, Zephyr. Good. Okay, so we will check the third part. Please give me an example for this. Noma, Unip, any example for this, for transitive? No? Okay, check it. 1 plus AB is greater than 0. Noma, this is not transitive. So we will just try to find an example for this one. Okay, we have this relation A comma B belongs to R1. Okay, now 1 comma 1 by 2. This belongs to R1. And we will take one more example, 1 comma 2. It is better to write like this. Hmm. 1 comma 1 by 2 belongs to R1 and 1 by 2 comma minus 1. Please check this, only this part, 1 by 2 comma minus 1. This belongs to R1 or not? Only if this is correct or not? We have this relation 1 plus AB
Sir,
is greater.
first one is correct.
Second. For second one, we will check A means 1 by 2.
Sir, second one is also.
This is also correct. Huh? 1 minus 1 by 2 greater than 0. 1 by 2 is greater than 0. Okay, so 1 comma 1 by 2 belongs to R1. 1 by 2 comma minus 1 belongs to R1. But 1 comma minus 1 do not belongs to R1. Hence it is not transitive. Okay. Hence it is not transitive. Okay. So please note down this. For third one, this is for transitive. Transitive. And confirm me on the chat box if this is completed. Then we will start the next question. Okay. Huzefa, this is clear. Huzefa, Mazia, Noma, this is clear. The third part. Huzefa, Mazia, Noma, this is clear. Third part. Okay, Noma. Huzefa, this is clear. Huzefa, this is clear. Okay, good. Okay, so I hope everyone has completed this. So now we will start the next question. Okay. Now please try this question. Determine each of the following relations are reflexive, symmetric, and transitive. This is the first relation. Relation is given and this is in the set builder form. So first of all, please convert this into the roster form. So that means first of all, please find R. That what is your relation? So this is given relation R on the set A. Set A have the values this 1, 2, 3, 4 up to 14. And this is defined as R is equal to X comma Y. 3X minus Y is equal to 0. Okay. So you need to take the value of X and Y from this set. You need to put this in this equation and then find the roster form of this. So anyone can tell me the first ordered pair of this relation. Anyone can give me a first ordered pair of this relation? Okay, Noma and Uni, very good. So first is 1, comma 3. Good. Josefa and Mazia, please check here. X and Y value you need to select from here. Okay, and this is your equation. 3x minus y is equal to 0. 3x minus y is equal to 0. So you need to select x and y from this set, which will satisfy this equation. Now suppose in place of x, if you will put 1, x is equal to 1 if you will put here. Okay, then check this you will get 3 minus 1. Then what the value of y should you need to put? Y is equal to 3. So you will get 3, this is equal to 0. Next value in place of x you can put 2. Okay, then the value of y you will get is 2 into 3 is 6. So you need 6 here. So next is 2 comma 6. Next one. Next is 3. 3 comma 9. Next is 4. 4 comma 12. If we will take the next value 5, then we will get a 15. But 15 is not present in this set. That's why this is a relation. Okay. So Noma, Unip, Mazia, Josefa, please tell me, this is clear to you? How you need to find the relation? Okay, Noma, good. Unip, okay. Josefa and Mazia, this is clear? Josefa, this clear? Okay, very good. Noma, sorry, Mazia, please let me know if this is clear to you. Now, please tell me the first one. This is reflexive or not? This is a very simple question. Please tell me this is reflexive or not. Please reply me on the chat box. Rishan, you have joined 1 hour late. Good, Noma, this is correct. Rishan, okay, good, Unip. Rishan, you have joined 1 hour late. Okay, Josefa, this is reflexive or not? Josefa, this is reflexive or not? No, very good. Now the elements in this set are 1, 2, 3 up to 14. But if you will see in the relation, then 1, 1, 2, 2, 3, 3, nothing is present in this relation. So we will say that it is not reflexive. Okay. So we will write 1 comma 1 do not belongs to relation R. Hence it is not reflexive. Okay. Hence it is not reflexive. Now second is symmetric. Second is symmetric. Okay, not symmetric. Very good, Nova. This is not symmetric. Okay, so if you will check here, 1 comma 3 is there, but it's opposite 3 comma 1 is not there. So 1 comma 3. Okay, in reflexive we can add one more line. This is sufficient, but if you wish, you can add one more line. No element of set A. No element of set A is related to itself. Is related to itself. To itself. Hence it is not reflexive. Okay, it's your wish, it's your choice. The second statement, you can add this in this answer, or the first part is sufficient. Now for the symmetric, if we will see that 1 comma 3 belongs to R, but 3 comma 1 do not belongs to R. Similar case is with 2 comma 6, 3 comma 9 and 4 comma 12 and 4 comma 12. Okay, same thing. 2 comma 6 is there, but 6 comma 2 is not there in the question, in the relation. Similarly for 3 comma 9, for 4 comma 12. Hence it is not symmetric. Hence it is not symmetric. Okay. Okay, so please note down this and confirm me, then we will check the third one. Okay. Third is exception. Okay, Noma, it is exception, the third one. So please let me know, Josefa, if this is done, then we will start the third part, transitive. Okay, done. Okay, now we will see the next part, transitive. Now for third part, C, for transitive, what was the condition for transitive is if A comma B belongs to R and B comma C belongs to R, then A comma C should also belongs to R. This is the condition for transitive. Okay. Now, what happens if these two are present? AB belongs to R and BC belongs to R, but AC do not belongs to R, then we will say that this is not transitive because it contradicts the statement. Okay. So please remember, in which case you will say this is not transitive when both these two should be present and third, this should not be present. Okay, please check it again. This is a confusing topic for transitive. Please remember, if AB is present, and in which case you will say that this is not transitive when AB belongs to R and BC belongs to R. These two are present and this is not present, then only we will say that this is not transitive. Okay, these two are present, third is not present, then we will say that this is not transitive. Now what happened if this is not given? Only A comma B belongs to R. Then in such a case, we will say that this is transitive. Okay, this is given in NCERT, so we need to follow that. Okay, so if there is only a single element, there is no other ordered pair, there is no other BC, then we will say that this is transitive. So we will write it like this. We will write like this: 1 comma 3 belongs to R, but there is no ordered pair. There is no ordered pair in which first element is 3. In which first element is 3. Okay, 1 comma 3 belongs to R, but there is no ordered pair in which first element is okay, I'm sorry, I missed this one. Yes, we have an example here, 3 comma 9. Sorry. Then it will not be transitive. Okay. Yes. So here 1 comma 3 belongs to R, and we have one ordered pair in which this is 3 and this is 3, and 3 comma 3 and 3 comma 9 belongs to R, but 1 comma 9 does not belongs to R, hence it is not transitive. Hence it is not transitive. Okay. So we found one ordered pair. That's why we are saying that this is not transitive. In case in the relation there is no ordered pair, okay, which form a transitive relation of first two component. So in that case, we will say that it is a transitive. So we'll check a further case. So here we get this element 3 comma 9. So 1 comma 3 belongs to us, 3 comma 9 belongs to us. So we will say that 1 comma 9 also do, and sorry, and 1 comma 9 do not belongs to us. So we'll say that it is not transitive. Okay. Munib, Noma, Mazia, Husefa. This is clear. We will check that case in the second question. Okay, good. Noma, this is clear. Josefa, this clear, this question, part C. Okay, good. Okay. So please note down this, confirm me, then we will start next question. Rishan, you have joined 1 hour late. I hope everyone has completed this. Okay, so we will start next question, second one. Next is this relation R on the set N of all natural number. Okay, defined as R is equal to this one. So first of all of you, please form a relation, share your answer, then we will discuss that it is reflexive, symmetric, or transitive. Okay, so everyone please find the relation for this case first. Everyone please share your answer for this. Please tell me what the relation you are getting. Noma, Munib, Mazia, Zephyr, Rishan, this is done. Okay, Noma. Not reflexive. Okay, Noma, first will you please share your answer? What the relation you get in this case? Munib, please share your answer. Mazia, Josefa, please share the answer. What the relation you are getting here? Our set on set. Noma, always please check the set. Okay, So you need to select the number from the natural number. Okay. Now, what's the relation? I will write on the next page. So this is y is equal to x plus 5 and x is less than 4. Y is equal to x plus 5, x is less than 4. Okay. And this belongs to natural number. Okay, Ani, very good. Now in this case, what will be the relation? Relation is what? R is equal to. First, you will put less than 4. So less than 4 means we can start only from 1 because there's a set of natural number. 0 do not lie in the natural number. Now 1, we will get a 6. 2, we will get a 7. 3, we will get a 8. And just only these three numbers we can put, okay, because x is less than 4. So we get this relation. If we will check first reflexive, so no element of set n, no element of set n is related to itself, is related to itself, is related to itself, hence it is not, hence it is not reflexive. Okay. So we have this relation, and we can see over here 1, 1, 2, 2, 3, 3, 4, 4. Nothing is present in this relation. So we can say that this is not reflexive. Now it's your choice. You can use this language, or you can just write 1, 1, 2, 2, 3, 3 do not belongs to relation R. That's why it is not reflexive. Now we will check for symmetric. Noma, very good. This is correct. Uneep, Huzaifa, please tell me, this is symmetric or not?
No, sir.
Very good. Huzaifa, this is symmetric or not? Huzaifa, this is symmetric or not? No, very good. So here we can write 1, 6 belongs to R, but 6, 1. Okay, no man, this is correct. But 6, 1 do not belongs to R, hence it is not symmetric. Hence it is not symmetric. We can write one more statement here. 1, 6 belongs to R, 6, and similar case with, and similar case with, and similar case with 2, 7 and 3, 5. Okay, hence R is not symmetric. Okay. Now, third one for transitive. As we have discussed in the previous case, if we do not find an ordered pair for the transitive, okay, so that means first and second ordered pair, then we will say that it is transitive. Okay. So if we will check here, 1, 6 is there, but there is no ordered pair which start with 6. 2, 7 is there. There is no ordered pair which start with 7. 3, 5 is there. There is no ordered pair which start with 5. Hence, we will say that this is transitive. Now, 1, 6 belongs to R, but there is no ordered pair, but there is no ordered pair. There is no ordered pair which start with 6. Okay, and similar case with, and similar case with 2, 7 and 3, 5. hence it is, hence it is, sorry, hence R is transitive. Okay. In which case we will say that this is not transitive, where the contradiction arises. What contradiction? We should have AB belongs to R and we should have BC belongs to R. We should have these two conditions. If we have these two conditions and third one is not given, AC is not given. Okay, if third condition is not there, then we will say that this is not transitive. But what happens if this condition is not there, then we will say this is transitive. Okay. So please note down this, confirm me, then we will check more question. Okay. Okay. Okay, Nomar. So everyone, shall we take a break of 5 minutes? Because we need to further continue this class for 30 minutes. Shall we take the break?
Yes.
Okay. So we will again connect in 5 minutes. Okay. Please do not log out from the class. Okay, so I guess 5 minutes are over. Josefa, Maziha, Unip, are you back? Unip, Josefa? So everyone, now please start part third. Okay, y is divisible by x. So first of all, please form a relation, and then we will check that this is reflexive transitive. Y is divisible by x. You need to select the numbers from here. Munib and Josefa, please let me know if you're back. Okay, so we will get this relation. First of all, we have select the first number as 1, as every number is divisible by 1. That's why we have taken up to 6. Then we have chosen 2. So 2 is divisible by 2. After that, 2, 4, 2, 6. So 3, comma 3, 3, comma 6, 4, comma 4, 5, comma 5, and 6, comma 6. So this is the relation we will get. Now, Uni, can you tell me this is reflexive or not?
Yes, sir.
Okay, good. Josefa, this is reflexive? Josefa, this is reflexive or not? Josefa, my voice is audible. Okay, one more thing. Tomorrow you have a subjective test of determinants. Okay, and the test will occur after our class. So I will take a 1 hour or 1 hour 15 minutes class, and the rest of 45 minutes you will have a online test. So I will be there in the room. Okay, so please revise determinant. You have a subjective test. Okay. Okay, so we were discussing about the relations. So this is reflexive. Yes. Okay, we can write the relation. Every element is divisible by itself. We can write like this, or you can just pick the ordered divisible by itself. Hence it is reflexive. Or you can pick the ordered pair from the relation, and you can show that all these ordered pair just give me. So in the second way of representing your answer is you can select this 1 1 2 2 3 3 4 4 5 5 and 6 6 from the question, And you can show that this is related to your relation. Okay, now the next one. Next is symmetric. Anyone can tell me it is symmetric or not. Munib, Noma, Josefa. Okay, Noma, good. Noma, any example for this? Munib, Josefa. This is symmetric or not?
No, sir.
Not symmetric. Okay, we can take any example. For example, 1 comma 2 is here, but 2 comma 1 is not present. Very good. Okay, so just give this example. 1 comma is there, 1 comma 2 is there, 2 comma 1 is not there. Hence it is not symmetric. Okay. Now next one. Okay, next is transitive. Anyone can tell me this is transitive or not? Anyone can tell me this is transitive? We have done a similar question some time back. Can you check the third one? This is transitive or not? Noma, Unib,
Yes, sir.
good. Noma, please check the previous question. We have already done y is divisible by x. This is transitive. Okay, you will not find any ordered pair which contradict it. Okay, Noma, please try to find any ordered pair which do not follow the transitive relation. Okay, so we will represent this answer in this way. Set is A. Okay, so we will represent in this way. Just symmetric. Okay, we'll say this is not symmetric. And same example, 1 comma 2 belongs to R, but 2 comma 1 do not belongs to R. Third one, transitive. Okay, so for transitive, it is given that y is divisible by x. So we will write like this: let x comma y comma z belongs to A. Now x comma y belongs to R. So this means y is divisible by x such that divisible by x, and this one y comma z belongs to R. So that means z is divisible by y, is divisible by y. Hence z is divisible by x, divisible by x. So x comma z belongs to R. Okay. Hence relation R is transitive. Hence relation R is transitive. Okay. Yes, Noma. 1 comma 3, 3 comma 3 is divisible. Yes. So Noma, we will not find any of the case which contradict this transitive. Okay, that's why we will say that this is transitive. This clear, Noma? Okay, very good. So please note down this. Then we will start the last question. Please let me know once it is done. Josefa, this is clear? Okay, very good. Okay, so Zephyr, this is done. Shall we start next? Zephyr, shall we start next this time? Zephyr, shall we start next this time? Okay, great. Uh, Now, please try fourth one. Relation R on the set Z of all integers defined as R is equal to X comma Y, X minus Y is an integer. So what is the set here? Set is Z. What is the relation? This is the relation. X minus Y is an integer. So please note down this question, and we will not form the relation here. Okay, because we will get an infinite ordered pairs. So we will not do that. We will try to solve this question directly. So please note down this question and tell me the first part. X minus Y is an integer. Is this a reflexive relation? Okay, Noma, very good. Your answer is correct. Munib, Huzefa, is this a reflexive relation?
Yes, sir.
Good. Huzefa, this is a reflexive or not? Okay, good. Now, we will check how can we represent this. Now, what is the relation? Relation R is equal to X comma Y. X minus Y is an integer. X minus Y is an integer. Okay. So for reflexive, we will assume like this. Let X belongs to Z. X minus X is equal to 0, which is an integer, which is a integer. Hence, X comma X will belongs to R. So R is reflexive. R is reflexive on Z. Okay, so what we have done in this question, we have selected element X which belongs to an integer. If we will subtract the same element, then we will always get an integer, which is 0. That's why this belongs to the relation R. This is clear? Munib, Noma, and Josefa.
Yes, sir.
Okay, Josefa, this is clear? Josefa, this is clear? This is reflexive? Josefa, yes or no? Josefa, this is clear? Zephyr, please let me know. Okay, this is a very tough chapter. So if you have any doubt right now, please let me. Noma, very good. This is correct. Munip, can you tell me the second part? This is symmetric or not? Munip, this is symmetric or not?
Sir, it will be sir.
It will be symmetric. Okay. So for symmetric, what we will do, we will assume two values. Let x comma y belongs to any integer, such that, and we will assume that this belongs to R. So what is mean by this belongs to R? That means x minus z is an, sorry, x minus y. x minus y is an integer. Okay, we assume two values from the relation, so that means this minus y is an integer. So x minus y, we can say this is equal to, is an integer, so we can say this is equal to lambda, and lambda is what? Lambda belongs to any integer. Okay, now x minus y is equal to an integer, so this means y minus x will become what? Minus lambda. And what is minus lambda? Minus lambda is also an integer. That's why this implies y comma x belongs to R. Okay, so finally we can write x belongs to x comma y belongs to R. This implies y comma x belongs to R. Hence R is symmetric. Hence R is symmetric on Z. Symmetric on Z. Okay. Okay, Vineet, this clear? Vineet, this clear?
Yes, sir.
Okay, good. Now third part. Noma, can you tell me the third one? This is transitive or not? Very good. Mani, please note down this, confirm me and tell me that this is transitive or not. Good, Munib, this is correct. So, Josefa, shall we start next? Shall I rub it, Josefa? Now, part C is transitive. Now, for transitive, we need three elements. So, let x, y, comma, z belongs to R. Okay, such that, sorry, so R is what? X, comma, y. X minus y is an integer. Is an integer. Okay. Now, part C is transitive. Now, in this part, we will assume three values. Let x, comma y, comma z belongs to capital Z. We have assumed three elements which belong to the integers, such that x, comma y is related to R. So that means x minus y is an integer. Next is y, comma z belongs to R. So this is y minus z is an integer. Okay. Now, if x minus y is an integer, y minus z is an integer, and if we will add these two, then y will get cancelled out and we will get x minus z as an integer. Okay. So we can write like this, x minus y plus y minus z is also an integer. Okay, and what is the property behind this? Sum of two integer is an integer. Sum of two integer is an integer. For example, if you have 2 and 4, you will add 2 and 4, you will get a 6. If you will take any integer, for example, 1, 2, 3, 4, 5, 6, any numbers, any integers, if you will add them, you will always get an integer. Okay, so there's nothing new about this. So this from first we will get x minus y is an integer. From the second we will get y minus z is an integer. Now if you will add 1 and 2, we have added these two. This should also be an integer. So in the bracket you can write sum of two integers is an integer. So if you will add these two, you will get x minus z is also an integer. So that means x comma z belongs to R. So we will write x comma y belongs to R and y comma z belongs to R. This will give us x comma z belongs to R. Hence R is transitive. Hence R is transitive for all integers. Okay. So Munib, Huzefa, Noma, this is clear. Noma, Munib, Huzefa, this clear.
Yes.
Yes or no? Most of the time we waste on asking you the same thing. Okay, no matter. So Huzefa, please reply me on the chat box. So in this chapter, the difficulty which you will face is how to represent your answer. Okay. So we will try to complete most of the questions in class only. And after completing this chapter, we will try to solve some previous year questions. Okay. So thank you very much. No homework for today. Please revise all these questions again. We will continue this same topic tomorrow. And please revise the determinant. Tomorrow you have a subjective test. So I will be there in the class. You need to give the test in front of me and submit it online. Okay. Okay, then thank you. You're welcome.
Sir, can you show the previous slide?
Yes.
Sir, the solution of the symmetric.
What do you need?
The solution of the symmetric.
Solution of symmetric means?
तो मतलब फोर्थ का ही जब हम प्रूफ कर रहे थे कि ये सिमेट्रिक
हाँ अच्छा वो चाहिए था वो एक्चुअली मुझसे डिलीट हो कोई बात नहीं ये नोट कर लिया उन्हें
यस सर
ओके
सर आई विल डू इट
okay only man if you have any doubt then please let me know in the next class.
Okay sir, thank you.
Okay, welcome. Okay, Huzefa, then we will continue this topic tomorrow. Okay, Huzefa, you're welcome.